I was going to say, no wonder it went so well. Yeah, they just let me do my thing. Yeah. See, they stay out of my way. That's the difference. I don't know. All right, so guys, no, in all seriousness, let's go and take a look at this next problem. Like I said, we do want to get this changed. And frankly, the reason why I changed it was so it would fit better on the graph. Again, it wasn't that, oh, the other one would have been so much harder. This is going to fit better on the graph. So, again, you say what graph? Fair, yeah. Sorry I didn't give you a graph on yours. It's my fault. All right, so as we take a look at this, as you can see, I'm trying to graph a cosecant problem, which means that for my first step, I'm going to rewrite this, not as a cosecant, but what am I going to write? -2 of what? What's the reciprocal of cosecant? Sine. Good. So this is what we're actually going to graph. Now, would you agree that that's what we did yesterday? That's a 4.5 problem now, isn't it? So from section 4.5, let's identify A, B, C, and D. So are we all in agreement? A is -2, B is 1, C is pi, D is 0. Now, I apologize if I'm going too quickly, but again, I feel like that's the part that we are really, really confident with so far. Okay? I'm also noticing that A is negative. What does that tell me? A is negative. That there will be a reflection over the x-axis. All right. Amplitude. Amplitude. That's the absolute value of A. So the absolute value of -2 is 2. The period is still 2 pi divided by B. So 2 pi divided by 1 is 2 pi. The starting point, it's still C over B, comma, D. So C over B, pi divided by 1 is pi, comma, D is 0. All right, so exactly as we would have done yesterday, we now go to build the frame. My starting point is at pi, comma, 0. There's the starting point. From there, building the frame, I need to go up and down. How much do I go up? Why 2? You're right. Because that's the amplitude. So I'm going to go up the amplitude. I'm going to go down the amplitude of 2. I need to move to the right 1 period, which is how much again? 2 pi. So my outer frame is going to look like this. So once we have the outer frame, we're going to break up the interior, cut it in half horizontally. We're going to break it into fourths vertically, like this. All right, so remember what we're graphing right now is a sine curve. Those of you that are saying, wait a second, I thought it was cosecant. Yeah, it is, but give me a second. First thing we're going to do is graph the sine curve. So if this is a sine curve, we know that that's what it would look like. But what's the difference? Reflection. There's been a reflection. So we're going to follow this pattern, not going up to the right, but down to the right. Also, sine goes through the origin, so should we go through the starting point? Yeah, absolutely. Sine goes through the origin. Starting point is merely the new origin, so that's what it's going to look like. Okay, so if this were a problem from yesterday, graph the sine, we'd be done. We'd move on to the next one. We'd be really happy about it. It's not a problem from yesterday, though. This is not actually a sine. We're trying to graph the cosecant. So now we have to start thinking about the reciprocals. So where I like to start, call it personal preference, where I like to start is with the intercepts. What's the reciprocal of 0? Yes, but what's the reciprocal of 0? It's undefined. So graphically, if something is undefined, that will lead to a vertical asymptote. So I'll have a vertical asymptote through each of my intercepts of the sine curve, which are very conveniently lines on my frame. So what about this minimum point right here? Minimum point, the reciprocal is going to become a what? Become a maximum point. What about this maximum point? What's that going to become? Thinking reciprocals. It's going to become a minimum. All right, now, I'm going to just erase some of this stuff so we can just focus on the graph. We would have wanted that. So here's the deal, though. In all seriousness, some people look at this graph, and boy, does that seem busy. There's a lot going on up there. Jonathan.
Does it matter how close we get to the asymptotes?
I mean, you can't cross them, can't touch them, but so as long as you're not doing that, I mean, we should approach them for sure, but short answer is probably no. Okay. All right, so guys, if you're looking up here and you're thinking, oh, there's just a lot of stuff going on up there, do we understand? So, guys, the way that I would say, you really have about 3 options with how you want to play this out, and I honestly don't care which way you do it. Option number one, especially as people are starting, which is very much where we are, oftentimes people draw in the sine and they just leave it. And that's okay. If you want to leave the sine curve, that's fine. Second option is people draw in the sine curve, then they get their cosecant, and then they go back and they erase the sine. Okay, that's also fine. That's the opposite of what I wanted to do. Let me try that again. That's not going to let me move that, is it? Okay, it's all locked in. The third option is that when we draw the frame, and we know what the sine curve is going to look like, it's going to go through these 5 points. Do you think that we could probably, without drawing the sine, know where the reciprocal pieces are going to go? That's our third option. You will get to that point. Just might not be today, and that's okay. All right? So, guys, I am going to record this next part, but in all seriousness, what's going to be the only difference?
It doesn't go through.
We're going to rewrite this as cosine of 2x plus pi over 2 plus 2. So, like I said, I'm going to record this next part. Again, we're not going to finish that. All right, so picking up with this next problem, like I said a minute ago, if we could do the previous, we can do this next one. This time it's a secant problem, so what we're actually going to be graphing is a cosine. Again, we're translating this and changing it now as a cosine. So again, from there, same approach, identifying A, B, C, and D. A in this case, leading coefficient is 1. B in this case, the coefficient in front of the x is 2. C, the amount being subtracted from the x is going to be a negative pi over 2. And D, the amount being added, the constant being added is 2. So once we have this information, again, A, B, C, and D, that's going to be very helpful for us. In fact, that'll allow us to identify whether or not we have a reflection. So first off, there is no reflection. The way that we know that, again, we focus on A. If A is negative, there's no, or excuse me, if A is negative, there's going to be a reflection. But here in this case, since A is positive, no reflection. Next up, the amplitude. Amplitude is just the absolute value of A, so the absolute value of 1 stays with 1. My period, remember the way that we find the period is 2 pi divided by B. In this case, B is 2, so 2 pi divided by 2. We're going to notice that those 2's definitely cancel out, and we have pi remaining. So the period is pi. And then our starting point, excuse me, the starting point, the way that we find that is going to be C over B, comma, D. So as we put C, which is negative pi over 2, divide that by B, which is 2, comma, D, which is also 2. Like that 2 showing up a lot here. Remember for that horizontal aspect, the negative pi over 2 over 2, when you're dividing fractions, you're really multiplying by the reciprocal. So that's really negative pi over 2 divided by 2 is really times 1/2. Now we hopefully are feeling really confident with the understanding that we have negative pi over 4, comma 2. All right, so once we have these pieces, I'm actually going to shift my graph down a little bit, just so I have a little bit more space to work with. All right, probably going to require me to go back and forth a lot, but again, I think it's going to be worth it in the long run. So, as we're taking a look here, the starting point was at negative pi over 4, comma 2. So negative pi over 4, I know that that's not on my x-axis, but I know that negative pi over 4 is going to fall right in between 0 and negative pi over 2. So negative pi over 4, comma 2, that will be located right here. We build the frame by moving up the amplitude. So my amplitude is 1, so I'm going to go up 1 unit. I'm going to move down the amplitude. Amplitude is also 1. So up 1, down 1. Now we're going to move over the period. So the period, remember, is pi. It's not 2 pi in this case. So I'm going to move over the amount of pi. So we're over pi, and now we have our outer frame. Once we have the outer frame, we're going to cut it in half horizontally. So horizontal, excuse me, horizontal line is going to go through the starting point. Now we need to break it into fourths vertically. So we're going to begin by cutting it in half. And then we're going to cut each half in half. So now we have our entire frame, and we are in business. So remember, our entire focus right now is on graphing y equals the cosine of 2x plus pi over 2 plus 2. As soon as we have that accomplished, then we're going to shift gears and turn this into a secant problem. But for the time being, it's a cosine problem. So we know off to the side what a cosine curve is going to look like. It does not go through the origin. It starts 1 unit above, and we're going to loop down and make it look something very roughly like that. It's pretty ugly. But There's also no reflection, so I know that, again, fully expected we're not going through the starting point, but instead we're going to start 1 unit above. So in this case, 1 unit or 1 amplitude above. We're going to go back down, something like this. So if we were asked to draw in the entire cosine curve, there it is. And again, if this were a cosine problem, we would be finished, but it's not. Remember that our true task is not to finish by graphing the cosine, but instead by graphing the secant. Okay, now secant is merely the reciprocal of cosine, so we just need to go in and we need to find the reciprocal of each of these key points. And like I talked about in class, where I particularly like to begin is with the intercepts. So the intercepts, or the zeros, those are going to be, if we think through it there realistically, the reciprocal of 0, 0 over 1, the reciprocal is going to be, well, that's undefined. So thinking on a graph where something is undefined, that's going to lead to a vertical asymptote. So we have a vertical asymptote through all of our intercepts, all of our zeros. So we have vertical asymptotes, in this case, at 0 and at pi over 2. Also, our maximum points. So again, here we have a maximum point. It will become a minimum point. So again, that will become a minimum point. This maximum point, again, will become a minimum point. While this minimum point down here, that will become a maximum. So what you see in blue, the asymptotes, as well as the blue curves, that is the secant. And remember, as we had talked about, let's see if I can get this out of here this time. Yeah, we could eliminate that. Oh, I thought I had it. We could get rid of this cosine curve if you'd prefer. Okay, so again, that would be our entire sketch. One of the other aspects that you may be asked to do, like for sure on next week's test, is to identify the relative minimum points. So our relative minimum points, again, our minimums, they're going to be located, again, first one, again, in that top left location, that appears to be at negative pi over 4, comma 3, whereas that last is located at, 3 pi over 4, comma 3. Our relative maximum points, in this case, relative maximum point, right about there, that's going to be located at positive pi over 4, comma 1. Sorry, a little sloppy. The other thing that we would be asked to do in this case, again, we could rest assured that they will, on a test or a quiz, even a homework assignment potentially, they'll ask where our vertical asymptotes are located. Remember, they're lines, so we've got to say, label them a little bit, that our asymptotes are going to be located at x equals, we said at x equals 0, and our second is located, looks like at x equals pi over 2. So again, labeling, that may be required from time to time, not only on homework assignments, but definitely on tests that we're going to take over Chapter 4. Okay, so that's as far as we wanted to get. Again, tangent, cotangent is going to be where we pick up tomorrow.